Love you too. Welcome back to Shaw Academy. We have some new content this time.
Wow, it's been like a few months.
We've moved on from the MIT version.
This is Maureen.
Hi.
He's making the boots for the reeds now for this organ. So the boots where all these reed blocks with the resonators and everything fits in and have their place. So that's 32. This is a 32 foot reed. I showed you in there in the voicing room the reed that I played.
The big reed, yeah.
It was about that long. So this is a 32 foot reed. That is the low C, and the resonator on top of here is 32 feet long. I mean, really, really, really long. And the frequency on this note will be 16 hertz. So it's below your hearing ability, the actual pitch, but you feel it. You know?
Oh.
Yeah, I mean, in a very profound way. You know that it moves the air.
What's this reed made of?
Brass. I mean, no, there's no reed there yet.
Oh, there isn't. Okay.
So this is what I cut out. For example, what you asked.
Oh, right.
That's the only thing in the whole organ that I use that machine for. Of these 12 notes, the low octave for this wooden face. So these get formed. The brass gets formed out of a flat sheet, you know, and then this gets soldered in, and then this gets glued on.
So
and then there's leather.
What gauge of brass do you use for your reeds?
So we have this special reed brass that we buy in Germany, and that comes in every 100th of a millimeter.
Oh, okay.
So we have many sizes, thicknesses. 100th of a millimeter. Do you know what
Yeah.
that is? Like less than
Tiny.
thousands of an
Yeah.
inch or something.
Right.
I can't even, I can't even.
Super thin.
And so especially for the small pipes, you know, 0.1 millimeter, then 0.11, 0.12, 0.13, and so on, you know, and so we have tons of sizes. So the very big reeds are made with the wooden blocks, and then the smaller ones we make with the metal.
I wonder if you can just play the lower octave and then not hear a thing, but just like feel it.
Yeah.
That'd be cool.
I mean, these reed pipes you actually can hear, but it's
Okay.
more noise, more like a jackhammer kind of a noise. But it makes only sense in the whole concept. I mean, when you play
when you're
everything
far away,
together, and when
It's
you
kinda-
also play a lot of sound on the rest of the organ, you would never
awesome.
play that by itself.
Yeah.
Wouldn't make any sense.
Sweet.
But here we, at least we used to, you know, work with the bone. This is cow bone for the keyboards.
Yeah.
So, I mean, we still use cow bone, but now we buy pieces. So we would have them from the slaughterhouse. You know, it's only works, the shin bone of the cow works. Only the hind legs. So you can make 2 keys out of 1 cow,
Oh, wow.
basically.
So those are expensive. Yeah.
So anyway, this gets, you know, then you cut them apart, make one flat surface, and then the next thing is to cut them to width. And then the next thing is to cut it, you know, to something like that, to the width of the key, the thickness. And then this gets glued on to a wood. The key itself is actually 2 to 3 feet long. You only see that much, you know, where you play. But the actual key goes way back.
Lever, yeah.
Level, yeah. So we make also
Cowbone.
like labels and things like that, you know, out of the cow bone, because we can't use ivory, of course. So, but cow bone has been a traditional material for hundreds of years in some areas of Europe, where there was no ivory, or ivory was always expensive, kind of, you know. So here we make lots of things, parts like this, like squares. So that's how the direction changes in the mechanical action from the key to the valve. So we make these parts. See, we don't want that noise. How it squeaks.
Why it's in the valve.
Yeah, well, this would have to, these are, before they get used, they get forced a little bit into it, so they get a little more springs for the valves. These are the springs that hold the valves closed.
Mm-hmm.
Yeah, see parts like this. There are like several thousand of these in there. Poor person that has to make those all. So these are made out of hornbeam. It's a really hard wood, but it's also kind of oily. So they're used for bottoms of hand planes because it's so hard, you know, so it doesn't mar.
Mm-hmm.
And also the oiliness helps from keeping the shavings off, you know, so they don't stick. So we have some interesting aspects of crafts that involve all these mechanics, you know, because everything has to work. If one thing doesn't work, you can't play the organ, really. If something, for example, sounds without pushing a key, called a cipher, the organ is not usable, you know. It might be only a turn of a little nut, you know, a knob in the back somewhere to get rid of it. Sometimes I go somewhere, kind of a disaster call, you know, and I go there and I'm done in 2 minutes. You know, just and it's always easy to, or typically easy to find mechanical problems. You can follow the tracker, the mechanical linkages, and then somehow usually see what's going on, where the problem is. There we have bellows. There are 2 smaller ones, and then here there are really big ones there. They're on their sides now, so the top part moves out with that white leather. It moves, it's a reservoir. Each division gets one of those.
Sorry.
More pipes. You see, these are stoppers. So these are, that's for tuning. That's where it gets tuned. So it has some felt and leather. So the felt is there so it can compensate for changes in climate. I mean, not the global climate change, but between
Little
summer and
ones,
winter.
yeah.
And this has to be sort of tight enough to stay, but also loose enough to be able
Take
to
it out,
move it
yeah.
and tune it.
How
See
often
this part, now they're closed, so the air is tight in there, so they don't move. But if there was a hole in there, so this top part would move all the way up to here with these borders. You know.
So how long did you say you've been doing this?
About 40 years.
Wow.
Actually more, actually, yeah. 42. But here, I've been here just about, next year will be 30 years in this shop. And that's when I started my own business. Oh, here are the valves. I can show you. So this is a typical, and here is even a better one with a wire. So here there's a pin here to hinge, like the hinge. And then there's a guide pin here in the slot in the front. So it stays sideways in place. And then this, when you push a key, this would be pulling on that and opening it just about like this. And then there's a slot under there, you know, where the air goes in, goes to the pipes. This is, this wood is, we call it cooked wood. It's thermally modified wood. So it's artificially cooked under the absence of oxygen, because with that temperature the wood would just catch fire. And on the way to charcoal, basically.
Mm-hmm.
You know, so it takes out the life of the wood, which means it won't get influenced by humidity, you know, or something. It cannot warp. It will stay the way it is. They invented that in Finland at the university, a system that the goal was to be able to use wood that's not high quality or rather low quality, but to make a good product for, well, not for organ builders. They didn't think about organ builders, but more for like siding and deck wood, and you know, because it doesn't rot.
So it takes all the moisture out?
It takes the moisture out, but also it destroys the cells, the living cells. I mean, it must be basically the moisture.
It stabilizes it.
Yeah, But you can, I made a cutting board out of this and put it in the dishwasher. It doesn't warp, you know, a typical board would just warp immediately, you know, drastically in a dishwasher.
So does that thermal wood act like hardwood but just way cheaper?
Not really cheaper, but it's very stable. You know, it doesn't move, so that's what we are after. We like wood. Also, in anything that we make, we always look at the board, how to cut it, for it to be as stable as it can be down the road. You know, in between, you know, all the seasons going through. Could easily be if there wood, like this is kind of a wild-looking wood going to grain like this. Probably wouldn't use that necessarily, but in this it doesn't matter. You know, you can use it. Therefore, you can find now lumber that we can use for these kinds of applications that would be hard to get untreated lumber that do the trick. It used to be when there was more old growth wood around. It was really very good, very relaxed. You know, the outer layers of the wood are the best, not the very center. So, but that's, you know, I'm glad they don't cut those trees down anymore. But we can deal with it. You know, but it is a fact. You know, it did change. During my career, we were able to get redwood for this kind of thing. Very fine grain. I need to see if I forgot any kind of major.
And I was just talking to your fellow, you do the blueprints also, right?
Blueprints. And Marcus, he checks my blueprints, you know.
I'm sorry?
And Marcus makes sure that they're right.
Yeah.
When he makes the list, he puts a lot of thought into it, because when he makes the list for all the materials and the wood for my drawings, he finds, you know, mistakes here and there.
This isn't going to fit, so we'll make it.
Yeah. And
But
hopefully
see-
every employee.
But see, that's the whole thing. You do everything. You meet the client, you talk to them.
Yeah, it takes it's a
and-
curious combination of things, you know, but that makes it fun.
So when did you start like working on like making organs? You said you were in church when you were young. When did
Yeah,
you
and
start,
then,
like, learning how to
I
make
wanted
them,
to
actually?
start organ building when I was like 15,
Oh, yeah.
after 9th grade, which in Austria you can go into
An
trades,
apprentice.
you know, apprenticeships, but then my parents talked me out of it at that point, and they thought, you know, I had 2 left hands kind of thing, you know, not very good with mechanical things. But they just didn't know. I made all the time. I made stuff. I didn't like grease. I admit that. You know, I didn't like to work on motors, and because my brothers, they always had mopeds and cars and things. They always had greasy. I just kind of stayed away from that more, and that's why they thought I didn't. I wasn't fit for something like this. But then later on, after high school and some minor college thing that I did for a while, I started when I was like 23. An apprenticeship, which for over there it's kind of unusual, not so much anymore, but back then, you know, you're supposed to be done with your
Apprenticeship.
be productive and start a family and stuff like that. But I never lost my interest, and then I also realized that there was an organ builder nearby where I could ask for an apprenticeship position.
So you came back to your true leaning.
Yeah, no, definitely. Yeah, I'm glad. Because what I did in between, I just couldn't. It was much lighter work, but I was totally worn
Yeah,
out.
I wasn't
you know.
very interested.
Because, it's things that don't interest you just wears you out, you know.
So how did you find your way to like New York from there?
Well, they
worked for the apprenticeship and
sent
then-
me over to the States here and there, you know,
Yeah,
a few times. And met organ builders and met people that wanted me to stay, and I did. I thought I tried it out, you know, and then